And let me talk quickly about the systemic Zeitgebers. So, how does the SCN synchronize the whole body? And so, the SCN has a number of outputs and it could send out signals to the rest of the body, basically, just like a leader of the country would send out its generals to the rest of the body to do its bidding. And you could see here that the SCN has outputs to the dorsal median nucleus of hypothalamus, which regulates largely wakefulness and feeding. But it has signals out to the median preoptic nucleus, which involves thermal regulation, and the paraventricular hypothalamus for corticosteroid release, melatonin, and autonomic nervous system. And the ones that are truly important for synchronizing the body are these four: temperature, corticosteroids, melatonin, and the autonomic nervous system. And I'm going to talk a little bit about those four in more detail here. So, melatonin is often called the hormone of darkness because its secretion is tightly linked to nightfall. This applies to nocturnal animals as well. So, even though nocturnal animals are awake during the nighttime, the melatonin levels are high even at the nighttime for them, even though they're awake. And as you can see on this graph, melatonin rises in the evening around the DILMO or dim light melatonin onset and peaks during the night and then falls towards the morning. And its effects are widespread. So melatonin promotes sleep initiation, and you can see that here it sort of increases the sleep propensity. It acts on receptors in the brain. It lowers the core body temperature by causing vasodilation. And it shifts the body from an active energy using state to one geared towards repair and recovery. It also has antioxidant effects, immune modulation, and it also feedbacks the SCN to reinforce the circadian rhythm stability, essentially reminding the system that it is night. Also, it's important to recognize that melatonin has a number of receptors, and the MT1 and M2 receptors are ubiquitous across the body. And so, if melatonin is the hormone of darkness, cortisol is its counterpart, the hormone of awakening. And as you see here, the cortisol levels rise sharply toward the end of the sleep period. And it rises particularly, it has a second bump right at the time of awakening. And this is called the cortisol awakening response. And this surge resets the body system, shifting the physiology from the anabolic repair focused state of night into the catabolic energy mobilizing state, ready for daytime activity. As their cortisol boosts the metabolism by raising blood glucose and mobilizing energy stores, it enhances cardiovascular tone and supports blood pressure and promotes alertness and wakefulness. And also dampens immune activity and prevents excessive inflammation during the day. And so, in short, cortisol acts as an internal readiness signal, priming both the body and the brain for the demands of the biological day. And this is a study done recently where healthy men had interstitial, basically subcutaneous dialysis systems in the skin to assess interstitial and serum fluid cortisol levels over the courses of the day. And again, you can see that this is the period of sleep. And you can see upon awakening, you can see the increase of the cortisol and then steadily decrease through the rest of the day. This is for one individual, but you could also see another individual here where the elevation is delayed and occurs in the middle of the day. And we're increasingly seeing that individuals that are exposed to chronic stress, that have high anxiety, have PTSDs, then you start to have this type of pattern where the cortisol peak happens at different times of the day as opposed to the early morning. And you could also have attenuation of the cortisol over time as well. And so you can imagine that can affect our circadian rhythm, at least these systemic Zeitgebers. And so temperature is another key circadian output tightly regulated by the SCN. And so core body temperature follows a daily rhythm. It reaches its lowest point, the temperature nadir, about 2 to 3 hours before wake time. And skin temperature here, according to this graph, really behaves differently depending on the location. So for distal skin, like the hands and the feet, it warms up in the evening to promote heat loss and help with sleep onset. Proximal is more like the core temperature pattern, and the mean skin, which is probably around the elbow or shoulder area, is following more the distal. And you could see that actually right before you go to sleep, the reason that you have a rise in the distal skin temperature to help release the heat, and then that leads to the core temperature to come down. And these rhythms are more than just passive byproducts because they also provide systemic time cues. It helps to synchronize peripheral clocks across the body, and it's probably one of the most reliable phase markers used in circadian research. And interestingly, you can see here that even with just 1 to 2 degrees Celsius changes, it can affect the cellular activity for the rest of the body. And this is done with heat shock factor and CRRBP, which is sort of the cold inducible RNA binding proteins that are found ubiquitously throughout the body. And I hope that you're seeing a theme here is that cortisol, melatonin, and temperature are these systemic Zeitgebers that are regulated by the SCN, but it has effects to practically every cell on the body because they have receptors that are ubiquitous across the body. And then finally, the autonomic nervous system. This is a large study done by Google, and it used Fitbit data from about 17,000 Fitbit users. And you can see the changes of the heart rate across time through the time of the day. And you can see for men tend to have lower heart rate compared to females, but you can see a drop, the nadir of the heart rate around 4 to 5 o'clock, and then a peak about 6 to 7 o'clock in the early evening. And so you could see that, and this is resting heart rate. So it takes away any of the heart rate changes that you see with physical activity. This is a reflection of an autonomic nervous system regulated by the circadian system, where it's significant parasympathetic activity at night and sympathetic activity during the day, particularly in late evenings.